Welcome to the Algebra 1 Quarter 2 test review. The review is quite long and is broken up into 8 sections. And so I'll be grouping different sections in separate videos in order to make them not be so long and to make it a little bit easier to find your problem and, quite frankly, to make it a little bit easier for me to record them. And so this video will be sections 1 and 2. So let's get right into it. You will find the other videos, the links to the other videos, in the comments below. So, for this first problem, there's a couple different ways I could do this. I could do it graphically, and I could graph the line. The y-intercept is 2, the slope is 1. If I keep doing that slope of 1, rise over run, I get a line like that. The second line, the y-intercept is -2, the slope is -1, rise over run, and I get a line like that. And we can see that the two lines intersect at -2, 0. Now you could also do it algebraically, which is to say that since substitution, I could say that x plus 2 equals -x minus 2. So then I would add x to both sides, and I would get 2x plus 2 equals -2. I would subtract 2 from both sides, and I would get 2x equals -4x, -4. Then I would divide both sides by 2, and I'd get x equals -2. Then to find y, I would just plug it back into one of the equations, which is y equals x plus 2. Right, once again, using the blue equation. And that would be y equals 0. And we get the same solution we had before. You can even do this on the calculator, and if you haven't seen this, you may want to ask your teacher, and I'm just going to do it real quick. A couple different ways you could attack this. Maybe if I can get the calculator to come up. Is you put both equations into the calculator and you graph them. Then you look, you can have there's a couple different ways you can do this. You can have the calculator find the point of intersection. Or, if you would like, if you prefer, oh, this calculator doesn't have it. There's also, if you're using inequals, that's another way you can do it. And I don't know how I can get inequals on this. We'll have to figure that out later. So, that's that problem. For the second problem, here it's solved for one of the variables. So I'm going to go ahead and do this one via substitution. So -x plus y equals 6. But I know x equals 4y. So I get -4y plus y equals 6. I get -3y equals 6. Divide both sides by -3, and I would get y equals -2. And then again, I know that x equals 4 times y, so x equals -8. So my solution would be -8, -2. For C, this problem's a little bit longer, and so there's a couple different ways we can attack this. If you know how to do the matrix algebra, you could do it that way in your calculator. If not, what we need to do is we need to, because they're both in general form, which is ax plus by equals c, I think the best route for me to go is going to be elimination. So what I'm going to do is I need to have the coefficients of either the x's or the y's either be the same or additive opposites. 2 and 5 are going to be difficult to get the same, but 3 and negative 1 is easy because I can multiply this whole equation by 3. As long as I do anything in an algebra equation to both sides, it doesn't change the value of, or the truthfulness of the statement. The first equation, I'm not going to do anything to. Now, the coefficients or x's are now additive opposites, so I'm going to add the two equations together. 3x plus negative 3x is 0. Negative 5y plus 6y is y, and 6 plus negative 9 is negative 3. So I know that y equals negative 3. So I can rewrite the original equation, but instead of writing y, I know I can write negative 3. This will give me 3x plus 15 equals 6. I will subtract 15 from both sides, and we'll get 3x equals negative 9. Divide both sides by 3, and I'll get x equals negative 3. So, for part D, I have one of the equations solved for y, so I'm going to use substitution. So the original equation is 4x plus 2 times y equals 6. And I'm going to sub in negative 2x plus 1. So I'm going to have to distribute this 2. So I'll end up with 4x minus 4x plus 2 equals 6. Then I have to combine like terms. Negative 4x minus 4x is 0, so I'm left with just 2x equals 6. This is not a true statement, so the answer is no solution. Systems of equations. Determine the solution to each scenario below. Micah correctly solved a system of equations and found that the last line of his work to be 5 equals 5. This is a true statement, so the final answer would be that, and there's no variables, so this would be infinite solutions. For the next one, Tia correctly solved the systems of equations and found the last line of her work was x equals 4 and y equals 1. So the solution to her system is just 4, comma, 1. Amy correctly solved the system and found the last line of her work to be negative 1 equals 6. Well, that's not a true statement, so the answer is no solution. And we just saw an example of this type of problem right here. So that's sections 1 and 2, the review of systems. I'm going to go ahead and throw section 3 in this, actually, because this is also systems. Be careful. This problem had a small little kerfuffle in it, so we're going to go ahead and work it out. The hardest part of any of these systems word problems is creating the equation. So this will be r plus b equals 32. The number of blue cars plus the number of red cars in the parking lot is 32. There are a total of 32, and it says that they add up to 32. There are 9 more red cars. So if I put red on this side and blue on this side, and this is what messes with people, I need them to be equal. If there are 9 more reds, then I actually need to add 9 to the blues so that they are equal. Then I can just solve this using substitution. So this will be b plus 9 plus b equals 32, or 2b plus 9 equals 32. And subtract 9 from both sides, and I'll get 2b equals 20. Let make sure there's 22.5. I'm sorry, whoops, I messed that up. 2b equals, hold on one second. I need to grab my calculator to make sure I didn't make a mistake here. 32 minus 9 is 23. Sorry about that. If I divide both sides by 2, I'll get b equals 11.5. And then we know that r equals 11.5 plus 9. So r equals 20.5. Now, obviously, you can't have 20.5 cars and 11.5 cars. I don't know, maybe you can. I guess in this scenario, you look out in the parking lot and there's 23 cars. 20 of them are painted red. I guess I really should be using red for that. Red. 11 of them are painted blue, and one car, I guess, is, you know, if we look at it from above, it's half red and half blue. So what does this mean? A lot of times this means the person who's originally set the problem didn't double check their numbers before they did it. Next problem. Once again, the hardest part is writing the system, is writing the equations, which is all this problem asks you to do. It does not ask you to solve it. So, Mr. Smith purchased 8 tickets for $105. So, we're going to do A for adult tickets and S for student tickets. Now, if we add the number of tickets he got, that adds up to 8. But then we need to figure out the amount of money he spent. Well, it's $9 for an adult ticket, and it's $6 for a student ticket. And if we add that together, that'll give us our 105. And now we have our systems of equation. I could solve this, but the problem doesn't ask me to. This one does. So 2c plus 5a for child and adult was 5928. And the total number of tickets sold is 1,500. I think I'm going to solve this using elimination. So what I'm going to do is I'm going to multiply the second equation by 2. So the second equation will become 2c plus 2a equals 3,000. And I'm going to rewrite the original equation, 2c plus 5a equals 5928. I'm going to subtract them. I'll subtract the two equations, and I will get negative 3a equals negative 2,928. I'm going to divide this by negative 3, and I'll get a equals 976. So there was 976 adult tickets sold. So then, using this equation, I know that C plus 976 equals 1,500. So I'll just subtract 976 from both sides, and I'll get C equals 524. So my answer is there are 976 adult tickets and there are 524 child tickets sold. All right. The difference of two numbers is negative 12. And their sum is 32. I'm sorry, 34. This problem is a breeze to do, either substitution or, I'm sorry, elimination. And I can either add or subtract the equations. For this one, I'm just going to add them. So x plus x is 2x, negative y plus y is 0, and negative 12 plus 34 is 22. Divide both sides by 2, and I'll get x equals 11. Then to find the other equation, I'll just plug in. So we said, the second equation says x plus y equals 34. So I'll just subtract 11 from both sides, and I'll get y equals 23. And so my two numbers are 11 and 23. And that's it for sections 1, 2, and 3. I will be doing sections 4 as a separate unit because that's kind of a long one. And then section 5. Over there mislabeled on this sheet too. All right, well, we'll deal with that. So the next one will be on direct and inverse variation, but this is sections 1, 2, and 3.